Hey, good evening or morning, wherever you are. This is September 27th, approaching October, or 28th, September 28th, whichever continent you happen to be on. And we're doing our Bucky call this evening, continuing our examination, reading, and discussions about fuller explanation. And um, and I'm real excited. We're going to start on page 205. Manu, how are you feeling this morning, and what do you anticipate getting out of the call today?
Good morning. Feeling coffee? Um, well, yeah. Nice, Fred. Just coming in when you were showing your uh dual of octahedron. Was it the dual of octahedron? You had 8 triangles, right?
Yes.
Okay, yes.
It's
So
a
that's
Chirality.
cool. So that is the dual of the octahedron. What it did, it put all the edges, all the vertex to vertex in a gas-like, and what you have a cube that comes in the middle. That's the derivation. And I always like that, playing with paper. All you need is paper, scissors, tape, and glue. And the imagination will go boundless. So that is really impressive. I feel good. I feel ready to ride this train. I just bought my ticket. I'm on board. And yes, let's go. Joe, how do you feel? What do you expect? Is Joe still there?
Yeah, Joe's here. He's come chiming in.
Sorry, guys. I was gonna move it around here. I'm doing okay. Just getting used to a little bit new routine, and yeah, and mm, uh, we lost somebody in my Stoic group that was a really good friend, and just processing that right now, and it makes you appreciate the time that you have with people. So as what I'm looking to take away, just continue to work through and to learn from everybody else here, to be quite honest. Last session was really, really helpful for me, meaning Wednesday. And so I'm just looking forward to hearing everybody's comments. Lee, how do you feel? What would you like to take away from today?
Unmute.
By the way, Joe, I don't know whose mirror it is. Is it from your mom?
What's that?
The mirror behind you.
Yeah, that is from my mom.
Fantastic.
Thank you.
I love it.
She loved it. It was one of the things that we've always had, actually. It was always in our house. It was it's yeah.
Joe, that's the first thing I noticed. It's beautiful.
She loved roses. And I planted roses. I planted knockouts in front for her.
Perfect.
Not enough
Well,
light.
I feel wonderful. Last week, everything was flying around the air and wouldn't get into my brain until the very end when Richard, Manu, Fred, all of you made sense, and it came to life, and I'm loving it, and I'm praying that I have come to life along with it so that I can enjoy this week. Now, who's next?
Whoever you choose. Anybody but
Richard,
Manu.
how do you feel, and what do you plan to get out of tonight?
Yes, good day. Hello to everybody. I'm feeling in a modeling way. And the reason I say that is because of what Fred was just showing and what Manu was referring to. And we had our trimtab group this morning, and we were fortunate to have Stroopy from Germany spend pretty much the whole 2 hours showing us his modeling with beads and so forth. But we went through a really interesting exercise of using straws and strings,
Yes.
and the strings being something that you can um, work like a needle and push them through the straws, and that way you can have this sort of seamless connecting of the struts or the edges. And you can also see through a knotting arrangement how they can be joined at the corners and then move to additional struts to build the model that Fred was just showing and that Manu often talks about. It was really an exciting kind of morning to experience his hands-on way of teaching the, if you want, the geometry of thinking and doing it through this particular modeling way. And so you don't need scissors and you don't need paper and you don't need glue or Scotch tape or anything like that. But and it in doing the demonstration, you often wondered how he was going to be able to keep the connections of the struts continuing, um, and and because of the different ways that you can needle the threads through the straws and then back again in some cases, and then having different kinds of knots. All of this is really possible, and so it's just a seamless type of way of modeling the structures that we're talking about and the content of Amy's book. And the one thing that, and the other thing we are doing is we're reading passages of synergetics that is put up by one of the members. And one of the issues today was looking at the 6 motions, precession being one of them. And I've had troubles working with precession from the point of view it's considered when you have one axis, create motion perpendicular to that axis on a different plane. And it's referred to as an inadvertent spin-off from the axis of exchange. And I have been using precession in an intentional way. In other words, if you get the axis of 2 people working together, you can create a motion horizontal, perpendicular to that axis that represents going from trauma to healing or problem to solution, that sort of thing. What I came out of it today was an understanding of how the inadvertency of it is natural. If you do certain things, it'll just happen. But I saw the flip side of it, that you can also do it intentionally in the way that I was describing it, and the way I've been trying to use it in a personal relationship sort of context. So it was a great morning, and I'm looking forward to continuing that kind of ongoing learning, lifelong learning sort of experience this evening with Amy's work. So over to you, Stephen. How are you feeling, and what's your expectation?
Okay. I'm excited about today. I'm a little bit frustrated with myself because I didn't make a note of something, and I like to give credit where credit is due. So I'm going to have to look back, go through my history of videos to find this. But I came across one where the headline on the video was Platonic Representation Hypothesis, Patterns, Understanding, and AI. The actual topic was the geometric pattern that proves AI understands. That was the headline under the on the video. I've got to go find it. It should be right here, but I'm noticing in my history I wish I could break my history up into categories. I don't know how to do that. But here was the summary that I got out of the thing, and I went through and took over about a 4-minute time period. I took a couple of sentences and put together. In ChatGTP and other AI systems, all words and word parts are called tokens, and they can be represented as points in a high-dimensional space. They were training the AI, ChatGPT specifically, to look at family trees. They didn't give them a tree. They did not give the AI the family tree. They just started talking about relationships. They talked about relationships in the family tree of the Kennedys. Then they talked about the royal families, the relationships, and said this person was this person's son and this person was this person's uncle, and just gave a random spew of these relationships. And then we trained AI to correctly predict who was the son of whom and who was the uncle of whom, and so on. We also incentivized the large language model to learn it in as simple a way as possible by limiting the resources that it had. We discovered, and here's the punchline, a whole bunch of independent systems had learned. In other words, they did this with ChatGPT and other systems, and they did it with French language and in English language and different languages. But what happened was all of these large language models came to the same conclusion. They all ended up building trees in order to explain the relationships. And they didn't tell AI that there was such a thing as a family tree. They just said, here's this relationship, and this was the great grandson of this person, and just pot shot it through it. And the AI built a family tree, and they built almost the same function in French and in different languages. So their conclusion was that the geometric pattern that proves that AI understands, that's a highly opinionated headline. It's more like, and then he explains that this idea is about what is called Platonic representation hypothesis, where the brain organizes things into patterns, and that proves to us that we understand it. And by building that pattern, we can also speculate additional information because the pattern is present. But it's all about geometry, Platonic representation. That's exactly what we're talking about with what we're doing here. And I just thought that was really cool. It's a 30-minute little excerpt from a big, long conversation. But I was excited about the idea because these calls have taught me what I learned from Amy is the shape of space. I used to think that, that the cube falls over because of gravity. Why doesn't a tripod fall over? Why doesn't a tetrahedron fall over? Well, I could say, well, they're all leaning. It's the shape of space. That's the way space is built. So when a structure accommodates itself like space, you get a natural output. And they did the same thing here, called the Platonic representation hypothesis. I'd never heard of it. I just thought it was so exciting. And it had a lot to do with what we're talking about. So that's been my big epiphany, and I think we're going to continue those kinds of ideas here today as we continue in our book. Whew, I'm excited. So I'm looking more to learn about reality and how I think and how universe is organized. And it has to do with my own nature. It's like I'm not just an accident. I'm part of a lattice. I don't know. I keep thinking about stuff like that. All right, so that's where we are. That's what I'm thinking about. We're about to read on page 205. Any comments?
Steve,
Yes, any comments or questions before we proceed? Go ahead.
do you see what I read? What I
chat?
wrote?
Yeah.
Okay,
Yes.
let's take a look at that.
In spite of all its complexity and all the technology, it might never be able, never be possible for AI to be inductive. AI can feel.
Right.
And in order to have a complete, remember duality, you need to feel as you need to think. Those go together to make a unit, a quantum of energy that means something. AI is in a word of deductions. You stuff in a lot of data, it can predictively deduct a lot of relationships and solve a lot of problems. But there might be some simple problems that AI will never be able to. That is, AI is unable to do what we call the lag, to step out of the flow and observe and intuit. And that is a quality, you know, kind of sentient beings.
Mm.
We might be weak in the processing of huge amounts of data,
Mm-hmm.
but we have the ability to just forget about that data. Step out, just observe,
Yeah.
and intuit. And that is pretty powerful
Very.
because both go together with lag to form what you call a triangle. Boundary, space, time
Mm.
is a topological triangle. Time is you quantize and then you move aside to let it, or action, reaction, resultant. It is similar.
Yeah, that makes sense.
Yeah.
Are you complete?
Yes.
It's like
Cool.
event data. I'm sorry.
Fred, what's up?
I think it's too early to say where AI is going. It's AI is about maybe 5-6 years old. The one we know now, the ChatGPT, all the large language models.
Right.
It's like looking at humanity at the dawn of humanity when they were painting some animals on the side of the caves and trying to deduct where this is going to go. I think it's a little bit too early. Let's give it a chance to evolve and to become what it has to become.
I agree with you, and yet the idea at your point that it's 5 years old. I mean, my 5-year-old children need to be spanked, or they need to be threatened that they would be spanked. That was really good. Just say, "Hey, do you want to spank him?" They would straighten right up. All you had to do is get like a dog. All you had to do is get a newspaper and make it go pop, pop, pop in their ass. You didn't have to hurt them. You just had to shock their brain into coming to a new space. No, I like that idea. It's 5 years old. We have no idea what it's going to do. I like that point of view. And
But note that those that were painting already failed. Feeling
Yeah,
is
okay, that's an
Well,
feeling,
allegory.
but AI is not feeling. It doesn't have it.
But
right,
Yeah,
I agree with you.
yeah,
And go ahead.
I'm not worried about that now.
Yeah.
mm,
It
So
takes how many years at school? 13 years at school to train somebody for graduating from to high school.
yeah,
It's 12 or 13 or 14 years
boy,
maybe.
and 13 years
Um,
of AI is really scary sounding.
we're training models over a few months on huge data, but over a few months. Let's have a model trained on all the data we have for 15 years and see where that's going.
Agreed. I agree. Go ahead, Joe.
just really quickly, I don't want to get too, but I would just say this. I think that you can even model human feeling. It's just never going to be organic.
Yeah.
And if it's not organic, then that's problem. I mean, that's where, you know, the that distinction is significant. But I think you can model emotions. In fact, I know people that are actually doing that as a way of collecting data over a very, very large, well, I mean, population, and essentially modeling sentiment. And if you can model sentiment, you're basically starting to fill in what that event data, what it triggers. And so, and then in what Manu said at the end of there was action, reaction, and resultant. That's a really important point, because that's essentially getting down to the idea of event data, and then you can talk about space and time from there. But you can go say there's an entity, there is an event, and you go from one state to the future state from there. And then you can start to model that, and that's almost modeling experience to a certain degree instead of just using this probabilistic stuff. It's pretty cool.
Yeah,
I don't
I'm
know
really
what-
grateful. Go ahead.
I didn't add anything.
Okay, well, it did add something. I'm really grateful that Manu brought up this idea of feeling. I hadn't thought about it in terms of a platonic representation hypothesis. And I'm now beginning to think I hadn't even thought of feelings. I'm grateful, Manu, that you brought that up, because in my book, I have a whole system that I've developed about belief systems. And if I just may, I'll just share something. How are belief systems created? There's a I studied a thing called medical hypnoanalysis for for a couple years, and it was. Let me get some stuff out of the way here. Yeah. So here's how a belief system is formed right down here. And this idea that a person well, this is one theory. I'm not saying this is the way it is. I'm just saying as a clinical hypnotherapist, I used this model when I talked to people about how they felt and what was going on. So there's this onion ring of personal experience. These different events have different impacts, and they become like the onion, and they become onion rings, or skin on the onion as it builds up. And what happens is these belief systems start interacting together. And here's I want to show this part first. Up here is this is what's called a critical faculty, and each of these stimulations go into the brain, and some of them they're all related somehow to these belief systems. And what I'm getting to, the punchline in terms of relationships, is this idea down here, is that pretty soon these belief systems start creating solar systems, and they start creating galaxies, and they start interrelating with each other. Here, I'm going to get this one up here pretty big. It's going to be coming up here pretty soon. That's what that little arrow is doing.
Did you just update this, Steve?
Nope, this shit here is 25, 30 years old.
Jeez.
Um, and uh, and so, um, and I've never thought about, because in my book I talk about the difference between central nervous system response to stimuli, which some people call feelings. I feel I felt that you poked me with a needle. That's a central nervous system response to stimuli. But I've always been wondering about feelings. Well, where do feelings come from? And Manu just nailed it. It's about anticipating. It's being able to recognize a pattern and realize there's probably a node buried in that pattern somewhere. And as a clinical hypnotherapist, that's what I used to do. If I'm talking to this person and I'm kind of burrowing down on this belief system, well, let's talk about belief system number 2. And I start talking to them about, well, let's do about belief system number 3. So I start talking to them. They'll give me this outer edge of what they think. And then I say, well, how does that work? What does that mean? Where did that come from? They'll drop down to the next layer. And then while we're trying to get to the core of that belief system, all of a sudden they hit this other layer here and they deflect. Most people,
Oh, wow.
I hope you're all seeing this.
Yeah, can you
Um,
put that in the chat, please? I know that you sent that to me in the past, but that
Yeah,
just
I've got a whole PDF. I'll send you this whole PDF system. It's pretty cool. But they deflect and go into a different belief system because belief systems do not want to die, because belief systems are created in order to help the biological entity survive. And the belief systems work, and they work together, and they deflect in order to do that. And so I'm trying to burrow into three, and blammo, all of a sudden I'm into two. And then I'm coming down to two, and blammo, all of a sudden I'm into one, or I'm into five, because these things, and then they become a belief system just by interacting. There's no center to belief system number nine, but it's a composite of the interrelationships of those belief systems. Anyway, I didn't mean to get into this. I apologize. But what I'm excited
I
about,
love it.
well, thank you. I appreciate that. What I'm excited about is that Manu brought up the idea of feelings in relationship to this idea of the platonic representation hypothesis. And to think that my thoughts, what I've learned from Bucky is that my thoughts are geometric things that are out there and I bump into them. I experience those things. I observe those things. And but I've always wondered about how I describe feelings. Now I've got it down here, Manu, in great big points. It's about pattern representation. It's about pattern anticipation of a node in a pattern, I think. Well, I feel like this. I don't know for sure. I haven't experienced that node yet for sure, but based on my sensibility of reality, something ought to be there. It's kind of like an astronomer looking for a planet because, you know, uh, or a moon because the planet's wiggling, right? So there's got to be a moon, or, you know what I'm talking about. I should, anyway. That was exciting, Manu. Thank you. And I
You
love
can't shine without a mirror. Remember that.
that's right. And that brings up
Say
another
that again.
chapter in the book is the mirror.
And I put the comment that you can't create a sun that is space without imagining a black hole that is the boundary.
Cool.
So all of it, and your belief system is when the boundary is tested, because you want to shine, you want to dance within the limits. So you test it, you dance, you expand, you have more and more partners, and the group grows. You believe in your dance until you hit something that triggers to say that this is, then you break out. That is called a breakout. It becomes now a refraction.
Yeah.
You get out of a group at an angle. So you see now getting out of group at an angle, we start talking about what? The curve.
Angular momentum.
Yeah.
Angular momentum, which is my big
you
theme.
spin out, and then you imagine something else, or
Very
you create
cool.
something bigger.
Well, cool. I've been part of that group too, Fred. And I wish I had time right now, I'd be doing it. So I think it's worth your time and energy. Richard, you had a comment.
Yeah, I just want to pick up on the whole idea of belief systems, or what I have now conceptualized under the concept of validators. And I always was intrigued when I was working with triangles and concepts that represented the vertexes. But when I read Fuller, of course, I was introduced to the idea of the simpler system, minimum system, has to have four. And so I was started to think, well, if it has to have four, what would the fourth be? And I went through a number of sort of iterations, but I came up with an awareness that the fourth may well be the belief systems, is what I thought about first. And then I looked at the belief systems from the point of view of beliefs and attitudes and laws and constitutions and all kinds of things that sort of help to govern the way in which we relate to other things. And when I put the fourth corner into the other three, then I realized that the validator concept was connected to the other three. And so you can have this kind of thing that Manu was talking about, but you can have a validator that governs me, but that same validator unit can have something in it that governs society, let's say. It can have something in it that governs your family or your friends. And if those governing sort of beliefs are compatible, then you have kind of a coherent, harmonized sort of system. If they're not, then you get different kinds of tensional, conflictual exchanges or relationships between them, and you have a wonky, uh, in some cases, a very dysfunctional sort of system because of the central validator concept that is governing people in different kinds of ways and not always the most in harmony or coherent type of way. So I just want to bring that back out. Whenever somebody talks about validators or beliefs, I always come to that sort of four-part system that I've been working on.
Richard, that's exactly what we call tetra-words. You have to find that fourth to make sense of a whole, because it carries now a unit of energy. It carries some energy. And we talk about energy all the time. But I like to put some lightness on this. In New York, you have the Statue of Liberty. That Statue of Liberty, at the same time, should correspond in San Francisco to the gate of accountability. I'm talking to America. So it's important. Liberty, accountability.
Yeah. Some of us are listening, Manu, but most of us don't give a shit. So, okay.
No,
is
but
everybody clear?
it's been for most of the time, it's been to have an overwhelming power and to know that, you should use it in a certain way. It is important. That's what you call leadership of the world.
Cool. Just for everybody, I dropped a PDF file of that belief system stuff in the chat, so we can go from there. Any other comments or questions before we jump into the book? I'm so grateful for everybody's feedback, and I'm excited that the Platonic representation
You
hypothesis
got
had some
the other
meaning.
one in there too, both of them.
Which other one?
The PDF, the second one that you brought up with the rings.
Yes, it's in little format. I mean, it's there.
Oh, it is? All right.
Yeah, it should be on page 2, I think.
Page.
I'll open it up here.
No, I'm talking about the second one. I
The
mean,
belief system orbiting thing.
yeah.
The orbits are on page 2 down at the bottom right-hand corner.
Have you sent it, Steve?
Yeah, I dropped it. I dropped it in the chat, and I will.
Okay, I can see two drops
Oh,
here.
I
Okay.
see it. I see
We
it.
can
No,
download.
I
Yes.
see it. The
Yeah.
small. Okay, it's a small version. All right.
It's a small version of it. If
I
you
got
want me to send the big
No,
one,
no,
I
no.
can do that too.
I'm completely cool.
Okay, cool. I know you're cool.
Now you drop it. You didn't drop, Steve. You didn't drop in the chat. Can you
Yeah,
send me?
there's a PDF file in the chat.
I'm not seeing it.
It's right at the bottom, 9:36, my time. And I'll put it in the email.
Okay.
Do not fear.
Yeah.
Okay.
Okay.
Okay, I'm excited to share that, and I'm delighted that I didn't get too much criticism. Cool.
You don't take risks, you have no value.
Exactly right. I call that the BS
No, I've
system.
seen it, Steve.
Yes.
I've seen it.
Belief
Okay.
system. It's my BS. It's my good. I'm glad you see it. All right, let's go for a reading then if everybody's ready. I just have to click all the right buttons. Okay, good. And I'll let that go. Okay, here we go. There we go. We're starting on page 205, Duality and Domain in Sphere Packing. I'll read a couple paragraphs and then we'll just rotate around. Duality and Domain in Sphere Packing. Imagine that our closest packed spheres are actually perfectly round balloons. Supposing that they all pack tightly into a closed container, which ensures that their positions are fixed. We then try to picture what would happen if more air were suddenly pumped into each balloon. Remember that they are unable to move, preventing the natural reaction of collectively spreading out and taking up more space. Instead, each individual balloon expands and presses more tightly against its neighbors so that the points of tangency merge into planes of tangency. Beautiful. A bubble is only a spherical bubble by itself. The minute you get two bubbles together, they develop a plane between them.
Yes.
And I remember playing with bubbles. That's exactly my experience. We allow the balloons to grow to the extent that all available space is occupied. What is the shape of the balloons once they merge together? Remember that 12 spheres pack tightly around one, and so the tangency points between the spheres, which were located at the 12 four-valent vertices of vector equilibria, must now be replaced by the same number of four-valent faces. We are thus reminded that the domain of a sphere is closest packing, in Fuller's words, the sphere and the sphere's own space. It's a rhombic dodecahedron. Boy, I would really love to see some graphics on this stuff, because I almost got that. The above sequence provides an important insight into the space-filling ability of rhombic dodecahedra. By renaming this diamond-faceted polyhedron spheric, Fuller places considerable emphasis on its relationship to closest packing. The spheric is thus presented as a cosmically significant shape. The spheric, the domain of the generalized energy event, and consequently the domain of every intersection in the omnisymmetrical vector matrix. By the way, I want to say that when I did my belief systems, I had those all in two-dimensional circles. And of course, over the years, they became spheres, and now they're each are tori, and they're fractalated tori, which makes it even more complicated. So anyway. Synergetic thus arrives at its all-space fillers through investigation of nature's omnisymmetrical framework. IVM provides the context. A spheric is any one of the rhombic dodecahedra symmetrically recurrent throughout an isotropic vector matrix geometry. All space filling, each rhombic dodecahedron defines exactly the unique and omnisimilar domain of every radically alternate vertex, as well as the unique and omnisimilar domains, or any aggregate of closest packed uniradius spheres. Well, I understood the words. I didn't understand the concept. Okay, any comment up to there? Comments or
The first thing, yes, the first thing that you have to do is what you call relationship, right? Sorry. So if you take a sphere, you take the 12
Look at
radar.
what Fred's doing.
Yeah.
Fred has built it right there.
Yeah. You have the radar
Wow.
going out, and you start folding the sphere. The relationship is 2 by 2. So there is math, what you call is a count of 2 in a set of something. So you count 2 relationship in a set of 12. Because you have a relationship of two vertices, forms an edge. If you are counting that number of edges, there's a representation of mathematics that says, if we have 12 edges, is 12 times 11 divided by the 2. I think so. They call it, I can't remember very well, representation of, they call it, the symbol is C. N is the number of vertices of the sub that you want. And the bigger N is the number of vertices of a whole set. I know that I'm confusing you guys, but that's what came to my mind. And I counted in 4, for example, it is C2 in 4 is 4 times 3 divided by 2, which is 6. And 6 edges, 6 relationship is a tetrahedron.
So you're just
Mhm.
using that formula R equals n squared minus n over 2.
Yeah, it is about that. They note it in mathematics in the set theory.
It's
Is
combination.
C
It's
combination.
combination of
Yes.
2 amongst 4. That means
Okay, that's it.
you choose 2 amongst 4. And that's factorial.
Exact. Factorial.
That's
Okay.
factorial. I forgot the formula, but that's factorial is factorial n is n times n minus 1
N
times
minus.
n is 2 until n minus 1, which is 1. That means factorial 3, it's 2 times either 3 times 2 times 1.
Yeah.
Yeah.
Factorial 9 is 9 times 8 times 7 until 1.
Yeah.
This, I take a chance that I have the.
Are those magnets, Steve? Are those fair magnets or what?
This is sphere packing. This is the 12 spheres packed around one. And when
Can you take them? What I mean is that can you take them out?
No, I cannot take them out. They
Okay, they were glued.
They
Okay.
welded together. Actually, I have some that are taken out, but that's because the welding has failed.
By the way, to Steve.
When Stephen mentioned that he would like to see that, then I remember I had that. So I just wanted to show it.
Nice.
And Steve, do you see the voids?
Yeah,
Yes. That's it.
the voids.
The voids. And what are
The
those
spaces
voids?
between the
What
spheres.
are the voids, Steve? They are
They're
what?
phi. They're phi.
They are stars. Fred,
They are
showing you.
stars.
They are stars. So to the
Actually, they actually.
They're stellated cubes, right?
No, they're not cubes.
Diamond.
Actually, difficult to describe.
no, they are stars. To the sphere, they are stars. The sphere is compacting, and those voids are exploding. You have the duality there in your hands. So the real sphere is those two combined.
Hmm.
And you combine two, and then if you now take the center of the stars, take the center of stars and link them together and see what you get. Take those centers. You have 12 spheres. Fred, show again.
Take the spheres out, and then you end up with your
No, I'm talking.
octaedron.
What I'm saying is, Fred shows again, and then you see those voids around it on the 12th part, where on the 12th one there.
Yeah.
And then you take the center of those exploding voids, the centers.
Hmm.
And then you link them together. What do you get? You link them together at the surface. Something very interesting in relationship to the cube octahedron. I'm true.
Well,
We can do the exercise.
Oh,
Yes.
well,
I want to show you the spaces between those spheres. Here are the spaces between the spheres. Concave face, flat face. This is from St.
Yeah, but
James.
yes, and then what to the right, Steve? That's what I was talking about. You see to the right, yeah, that is the cube octahedron, and you have you see those vertices are the centers of the voids.
Well, we had this discussion last time. I don't see that as a cube octahedron, but that's okay.
Do you see the cube in the middle? You see the four faces? You see, yes, those four faces, it goes through. That's the cube.
But every face is stellated if it's between the things.
What we're talking about approximations. We know that the plane are not real plane. They are planoids.
So Fred, why don't you make those spheres and put magnets in them so people can build those things? And then put some clay between them so when you take them apart, the clay comes out, the little stars that Manu talked about, will have physical representations of those stars. I'm very excited about this.
Those magnets.
I'm sure if we have a
you-
magnet, yes.
When those magnets you have, the balls, can you bring them
It's
together?
not enough. It's not enough.
The
I'm
balls,
trying.
Can you bring them together, or are they?
no,
No, they are rigid. They are rigid. They are
the,
rigid of the same.
in these structures right here,
Yeah.
it's the sticks that are magnetic. The balls are not magnetic.
The balls are not magnetic.
They're not magnetic. They're just steel. And then the magnet is in the edge.
Yeah. But what I'm saying is, Fred, if we had enough in the box instead of having what we have there, if it were a bigger set, we'll be able to do it. We don't have enough. We don't have enough struts.
Well, I'm in contact with the factory. How many containers you want?
I like that.
Oh my goodness, I love it. I thought for a minute that the steel balls had been touching against the magnet so much that they'd become magnetized, but I realized that I had an edge in my hand and it was picking up the magnetism. The one ball was picking up the magnetism from the other ball, or from the stick, and then the ball was being attracted into it. So the steel balls aren't magnetic at all.
The problem with magnetic balls is that magnets are dual poles. They have two poles.
That's right.
And when you want to aggregate balls, magnetic balls together, you end up with something very unstable somehow.
Yes, I got that.
But that's why you have to think of polarity and how to put the polarity in terms of your whole is coherent. You do it. That's the way we do with a tetrahedron. If you put it in certain sense, it's going to explode. There is a way of putting them, of arranging the plus and the minus. You always have to have plus and minus arranged through a sphere. And those are the pole of the sphere for it to make sense. Because the whole stuff is to create fields that loop. And that loop like this and loop like that to close and make something to create a space. So you have the equator and the polar. Those that come together to always make a dual pair. And thus create the tetrahedron. And this has a lot to do with what Fred was saying the other day, that you cannot, how did you say it? It has to do with hands, Fred. How do you call it?
Chirality.
Yes.
I put it back in the chat if you like.
Chirality is basic. It is basic. You must have a gravity and a radiational pair for it to work at the base. We were created that way in everything, and that reflects everything in our universe.
We were talking about precession a little while ago. Chirality has a lot to do with precession as well. In which direction precession will take you. You need actually for chirality in physics, everything has to do with the way which chirality you choose, and physics has decided to choose the right hand. So you take the right hand and your fingers indicate which way the precession is going to go. And it's very important because if you make a mistake and use your left hand, then the signs get inversed, and instead of attraction, you get repulsion and stuff like this. To the point that some MIT students in physics, during the exam, they write on their hands, left hand, right hand, use this one.
Oh, I'll be darned.
Because in order to orient your system, you have to use the right-hand rule. And under the stress of the exam, some students just make a mistake and then it's all wrong.
Oh, cool.
And that's why is because we are from the origin in the system. We imagine we are in the system. And to see in the system, you have to decide to look left or right, to turn like this or like that. And that's where the origin of decision is from.
It's arbitrary, the decision of choosing left hand, right hand. For instance, physics is right hand, and computer graphics is left hand. Everything in computer graphics is left handed.
I'll tell you, chirality may be able to help you pass the test at MIT, but it does not answer the question, what is the sound of one hand clapping? And when it does that, I'll be impressed.
There's echo. There's echo.
I'm sorry. I apologize.
If you clap with one hand in a forest and nobody's listening.
Right.
But have you picked that because you are in from the origin, you must decide?
What?
I am in, therefore I must decide what I
course.
have to do. Or something else is going to decide for me. There's got to be a
that's the other
decision to
part.
make sense. Yes.
Are you guys telling me that chirality can be explained in synergetics? Is chirality convex or conjugate?
Yes, Steve. In synergetics, chirality is that make the four. And Steve said it, Fred said it in precession. Let's assume that you and me are in a sphere. And I choose to turn left. You choose to turn right. After a full revolution around ourselves, we are going to be face to face again. It requires 720 degrees of our pair spinning to make sense of us, to make one full cycle. So we are in, let's just say initially, I'm looking in the face of Steve. I choose to turn like this. Steve chooses to turn like that. Assume that we are turning at the same speed. What will happen is that when I have turned 340 degrees, 360 degrees, Steve will also have turned 360 degrees. And we'll find ourselves in the same position we were from the beginning. We've accomplished a cycle. So a cycle in the context of duality, in the context of us being in, is not 360 degrees, it's 720 degrees. And that cycle determines, a cycle has the beginning and the end. It determines our unit of account. We are spin once, that is it. Now, we decide to do that again. Or I decide to pause and see you doing. When I decide to pause and see two others doing, I will see where it goes. And when that is finished, the two others will find themselves face to face. But my perception from seeing their face to face is going to be one that is perpendicular to the axis of observation. Do you see the point I'm trying to make? I was dancing with Steve. We did a 720 degree. But Joe decided to be observing us doing that in the system. Right. Once we have finished doing that, Joe is seeing us through his mirror at 90 degrees to our face, to our axis of Manu and Steve. Joe must see us perpendicularly to make sense of it. How do you define that? It's called precession. And it is the angular momentum translating into the linear momentum in the observation of Joe. Joe is seeing like this. This is Steve and I, and Joe is this. That's where Joe sees this, that come like this, and reflect there. Joe sees this. Where's another pen? This is Joe's mirror. and it's perpendicular to Steve and I. That's it. That is precision.
Right. Okay. Actually, that's one of the best definition or explanations of precession yet.
Okay, if you're complete, it's Fred's turn to share.
I'm complete, Steve. Very interesting, but we must read further.
Thank you. I just wanted to jump in with this 720 and say that is one of the reasons that Bucky uses to justify that unity is plural at minimum 2. That's all I wanted to say.
Okay.
Cool.
Steve,
Okay.
you used to have graphics of the 720.
I do have some graphics on 720.
Say something?
Not to bring them up now, but it's just if you could share those. I mean, they were helpful. I think I have one.
Yeah, I did some graphic analysis. In fact, of the tetrahedron, the A, B, C, D.
Yeah, right.
And I put it on a chart. So there was the convex and concave, and you add the two together and you get up 1440 each one.
Right.
I'm not real satisfied with it. By the way, I'm going to go ahead and drop the Lee, you unmuted your phone. I'll mute you. I'm going to go ahead and drop the that paper on the platonic representation hypothesis, because it ended up being pretty significant. So I'm going to drop that link and everything in a PDF file in the chat here in just a minute, and I'll send it out in an email. Okay, good. Are we ready to go? You want to say something?
He wants to speak.
Lee?
I do.
You got to unmute. There you go.
Now, how did we get to cheese? And poor Manu saying that it was too expensive to show anything in cheese. I don't understand any of that. Now, is this part of this? The cheese being sliced up? Manu?
It could be. Yeah, it could be. It could be, Lee. Remember that the slicing, we don't hear slicing in 4. That is, was this one slicing 2, and Joe observing slicing 2. You can do that further to the 12. And then you're going to start seeing interesting things inside.
So in other words, you get a whole bunch of cubes in that circle.
Yeah, you could get the cube, as we say. It would did. You could do it with cube. You could. I just imagine it. You could cut. You could take a tetrahedron, because we chose the cube because you could make a tetrahedron of a 4 face. You could cut first cut like that, and then start cutting inside, and seeing the octahedron, and cutting the octahedron again, and seeing a lot of things. I haven't been able to do so.
I still don't see it. I got to see the cheese. I looked all over the grocery store for a big slice of cheese so I could do what you said. And they didn't have it. It was all sliced up. Darn. But eventually, I hope I will get what that meant.
Yeah. But in the meantime, Lee, it's very interesting to play with paper. Paper is an excellent model, because paper, you can fold it. So all you need, like Fred did, you need paper. I did this exercise with Steve long time ago, if you can remember. You take paper, you take a pair of scissors and glue, and this type of glue.
Oh, I know. It's
Paper glue.
Yeah.
Oh. You can do a lot of things, like Kitsu, like Steve said, and like Fred said in preschool.
Started the meeting today.
Yes, I love it. I really love it, because it allows you to get to to free your mind. You're just free of the other preoccupation, and just do what you have to do there.
Well, heck, I want to eat some of the cheese.
Yeah. Steve, if you can, I don't know, Steve is good at archiving. If you can go back to see when we we build a lot of things, Steve. You remember we built this? We built the dome, the geodesic dome.
Yeah, at the time though, that was Kelly, and that's
Yeah.
on Kelly's.
But
If we could
you
find
have,
Kelly's YouTube, we could do
I
it.
sent things to you. If you haven't lost your computer. You see, Lee, this is paper. This is paper. Look at how hard it is. I'm pressing here. This is just paper.
Goodness.
But you see here, you see there's a certain proportion of equilateral triangle to isosceles triangle. To make this, yes. And you can play with, you look at the inside, it's all glued. Look at the inside.
Pretty cool.
So you cut triangles, you fold the edges like this so that you can glue together, and you make this. This is my little cap when I have kids here. I put this on. Yeah. So you can do a lot of things. All of this is paper. When we were with this is Fred, do you remember this?
I did that experiment. That's the Mobius band. I did that.
Yes.
Fred, were you there when we cut up the paper?
We made
this
we
is-
made an experiment with Mobius bands.
Yes.
With 1 cut, 2 cuts, 3 cuts,
Yes.
4 cuts.
Yes.
Yeah, they are.
You were there.
You don't. I'm not that bad
Oh
at
my
keeping.
Manu,
Yeah, they are.
Manu,
These
let
things
me,
are
I
10
could
years old.
explain and they're trash, Manu. You can throw them away at any day.
You
don't need
be
to keep
careful.
them.
You be careful with your thing in storage there. We had
Yeah.
COVID in between, so you're going to reactivate some old strain of COVID from your.
Yeah. And then I'm just showing Lee. Lee, you see this?
Yeah,
This is cock. This is cork. This is wire, steel wire inside there. And this is paper. And then we use this messy, string here to just tie it. We're just, this is, and we play. You see this turn, this spins, this turn. You have a star. You can be inside looking through the windows and see a lot of things. It can do this. Why turning?
That's a prototype of the South African space station.
So we have a kind. Look, no, I'm just trying to encourage Lee to do things. This is a basic that you do. This is a tetrahedron that is completely unfolded.
Yeah, I
You see
remember
here?
that. I remember cutting that.
Yeah. But you can do this. Look at this,
That
Lee.
falls apart.
When you put it together back, look at what it gives. It gives you a tetrahedron. You see that?
Yeah, I remember.
So what I've always talked about, the tetrahedron and the hidden or the octahedron inside, and the division of it, those three, you can put them in this, and then you can count the faces.
I love that.
Now
You
I
see?
know that your wife doesn't have a key to your office. Otherwise, all this.
No, she doesn't have. Yeah, no way. When I was sick last year, she brought some people here. She said, "Look at what he's doing. That's what took him to that state." And she started showing all the trash here.
This is like show and tell.
Really
Yeah.
is.
But this we literally did it, Lee, and it's paper. It's just little things. You cut them, you can see them nicely. Look at this guy. He's doing this. He's hinging.
I love
This
it.
triangle. He's hinging. And it can hinge like that. And this is the basic of folding. This can fold like this. To become this, it can fold like that. It can fold like that. Look at this.
Great.
But it allows us to understand some basic stuff.
Let's
And this
continue to read.
This is my tinder box here. So here. This stage here, when the lady to clean comes here, she cannot do anything. I forbid her from looking at my desk. When it's dusty, I dust it off myself.
Well, I will tell you, Manu, that discovering that Mobius band changed my whole idea about the interconnectedness of everything.
Yeah.
And it blew my mind. So I'm actually honored that you kept that trash around. Just don't tell anybody about it, okay? All right. So, so here we go. Who wants to read from? Continue reading here. There we are.
I can.
Anybody?
Where
Okay.
are we?
Wait, I'm sorry, Brad, did you want to read?
No. I just want to follow up. Where are we?
We're right here in a later section of synergetics.
Okay, thank you.
Mhm.
In a later section of synergetics, Fuller expands upon the above observations with a more general statement about any point in space. The most complete description of the domain of a point is not a vector equilibrium, but a rhombic dodecahedron, because it would have to be
Hang on.
H2O5.
I know. There we go.
All space filling, and because it has the most omnidirectional symmetry. The nearest thing you could get to a sphere in relation to a point, and which would fill all space, is a rhombic dodecahedron. Truncated octahedron.
Hang on just a second, Joe. I'm sorry to interrupt you. I had an epiphany. When we finished our conversation, I found another graphic, and it was on last week's thingy-me-blop, and I'd like to share it because it actually talked about the background radiation, the microwave background radiation, and how it actually, I think it's set up in dodecahedron. Let me see if I can find that thing. Maybe I should let us continue to read. Let's see if I can find it right off the bat. It should be right here. Well, if this is organized by time, and it isn't yet organized by time. So let's continue to read, and I'll find it. It was it showed. I think the graphic is actually going to demonstrate the dodecahedron in space. So these nodes are not just vectors; they're dodecahedra. Wow, that's something. Okay, I'll find it when we go from there. Do you want to continue to read?
That's why the dodecahedron is the dual of the icosahedron.
That's tough.
Wow. I'm screwing around with my screen here. One of these days, I'm going to graduate to a.
Mac.
Thank you for the insult. I deserved it. I deserved it. No, I try to do too many things at one time with my computer, and so it responds in appropriate fashion. Go ahead.
Truncated octahedron. The truncated octahedron, or tetrakaidekahedron. I mean, does somebody throw me a bone here?
Tetrakaideka.
Tetrakaidekaedron. 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 Tetrakaidekaedron.
Yeah.
It's Greek.
Yes, it's Greek.
Notice that no English-speaking person was able to pronounce that word.
Yeah.
Because it's Greek.
No English-speaking native language. Because it's Greek. Go ahead.
Is also a known space filler, figure 12-4. A model of this semi-regular polyhedron can be constructed by taping together 8 cardboard hexagons and 6 squares of the same edge length. But Fuller is wary of that approach, a geometry which supports the illusion of solids. Instead, synergetics prescribes that we view the system in context. Therefore, to generate this shape, we start with a 3-frequency octahedron, with its edges divided into 3 equal segments. This octahedron submits quite naturally to vertex truncation, as shown in Chapter 9, Figure 9-9. a single frequency half octahedron can be chopped off from each corner, creating six square faces and converting the three frequency triangles into equilateral hexagons. That's basically it right there.
So this is the IVM right here in its most complete form is the dodecahedron.
Manu, there has to be phi somewhere in there. And
Yeah.
probably the ratio at which you cut the apex must be phi somewhere in there.
Well, I don't see 5. I see a square and I see a hexagon.
Yeah, but the where do you cut the apex of the starting shape in order to have a space fitting? The distance from the height. Probably the distance from the height divided by the distance you have to cut must be phi somewhere.
Well, I suggest that has to do with the center of gravity of a triangle. You remember the center of gravity of a triangle?
Yeah, I know, but why would that be related to space fitting?
Because weight concentrate at the, I'm just speculating, at the center of gravity. And you join center of gravities. Remember that the center of gravity of a triangle is always 1/3 to the opposite, from the base. If you put one of the edges of a triangle as a base, and the opposite, then therefore you have the opposite vertex, that is, the center of gravity is always 1/3 from that base to that top. Is a property of triangles. If I have a triangle like any let me just take 3 here and put together. I suggest, I'm not sure, I suggest that it has to do with, you see, if you take this, and then like this, here, if you take this, the center of gravity of any of these, of this triangle will be about here. Here. 1/3 from the base compared to 2/3 from the vertex that is opposite that base.
Why would that? That's not what it looks like that it's cut at that place. It's cut a lot higher than that.
You see, I don't know. I'm just suggesting.
The cut, in order to make that shape space fitting, the height at which you cut the apex or 6 apexes, there's only one height.
Well, but when you are cutting,
my guess was there's phi in there, but maybe it's not. I don't know.
But phi has been demonstrated to be actually linked to this, to that. Let me put another triangle here in red, and I'll show something. Here, just hold on. Just give me a second.
Plus, actually, that would be a ratio of the height of the pyramid, because the apex you cut is the apex of a pyramid. It's not a tetrahedron.
Look at the Star of David. Remember, you always have to. You cut there. That's now, I don't know, maybe 1/3. I don't know if it corresponds exactly to 1/3 because the ratio of right angles. Look at this. If I cut here, I cut here, I cut here. This is the way I cut this triangle.
You have a hexagon.
Do you see that?
In the middle. Yeah.
I cut here, I cut here.
You're truncating. You're truncating.
Yes. That's the way I truncate it. And then I consider this hexagon here.
Yes, but that's 2D. This is much more.
No, I'm just suggesting.
Yeah,
I'm not. It's just an idea that it might have to do. It might go that way.
it's no more triangle. It's the height of a pyramid, of a square base pyramid.
Yeah,
There
but imagine
there has
that.
to be
Imagine that,
triangle.
Steve, Fred. Imagine that this is two pair of triangles. Huh? Imagine that you have one like this, and then another one there, another one here, another one there, and then you cut that. Then you start having something. You start having the square here, because remember that every tetrahedron comes in two. There's
Yeah,
always.
yes, but how do you choose the height?
I think that that's what I'm saying. I think that it has to do with the center of gravity. The center of gravity of this one is here and that one is there. Like that. I think that it has to do. It has to do of a ratio of a square root. You know, you have a right angle here compared to the equilateral angle of 60 degrees here. It has to do with something with that. I'm just intuiting now. I cannot deduct, I'm intuiting. Maybe somebody should do some research on it and see. But I think that if you take this like this, and then you put another one, if I had 4 pairs, 4, because it's a tetrahedron, it's a double tetrahedron. So if I take, you know, it has, so a double tetrahedron has 8 triangles. Double tetrahedron has 8 triangles. If I put each pair of a triangle like this, and then I have 4 like that, inclined, and then I build them, and then I cut all of this expanding stuff here. I cut them off. I suggest that we'll have this. We'll have the cube octahedron. Now I'm thinking that it should be. I cannot demonstrate it, but this is it. If I could have 4 pairs, maybe we should try this with paper and trace it on the paper and cut the paper and glue the paper and see. If I had 4 pairs like this, because that's the way it comes. Or if I have, let's say, 4 stars of David of same dimension, and I cut the top like this, I put them together, I should obtain that stuff. Now I can see it now. I should obtain it. And 5 times 4 give me the 20. The 20 faces. That's it. That's it. I can take a risk now. I can take the risk. That's it. You take 2 equilateral triangles, you put them in a perpendicular position. That is, in a duality position, like this. You have a Star of David. You cut out the vertices of a star. So you have 4 hexagons. You put them together in incline like this, you should obtain the cube octahedron. I can see that now. Yes.
And what are you pointing out, Fred?
That's a pyramid, square base pyramid.
Right, half an octahedron.
BCDE is a square base.
Right.
And O is the center of gravity of the pyramid.
Yeah.
Say that again.
I think it's more complicated than just a 3D than just a 2D triangle.
Yeah.
Anyway, my feeling was 5 is in there, but it's just a feeling. It's just.
I think it is too.
No, we can. It's a good feeling, Fred. Well, it requires investigation. It really requires investigation. This is good.
Cool.
Let's Steve, you have this. Joe, do you have this?
The magnets? I do.
Yes.
It's
Okay. Let's try to experiment on that. We put the magnet and we cut the paper corresponding to what we want, and then we try to put it together. I think that it should be interesting. Okay.
Is that
Because
your
I can
homework
see
then?
like this. I can see that the Star of David.
yeah, easily.
If you want to, you know, there are 4 stars of David,
No, you could use this.
and each star of David
That's the only
takes
thing.
two triangles like this, each one,
Yeah.
and then you take the 4 and you put them at a certain angle to close, what you have somewhere, or the voids of closure, should be the cube octahedron. Because I can already see this. Look, if I take this one like this, and I put another one like that, look at this, and I cut here, 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 the link between this is a square. Here. You see this link here? This segment here, let me put it this way to see it. This red segment here that you can see in the front. You see the red segment. If I hit this, if I hit this side, you can see the red segment there now.
Right.
Yes, that red segment, when I put the three together, I'll have this, that, and that. I have a square. I have a square of that dimension. And the question is, that dimension in the incline, what is it? What is the length of this segment? What is it equal to? It depends on the angles of 60 degrees and 90 degrees. And the sine and tangent and all of this. I suggest that Fred, if we look into that clean, maybe we can get something. But I can sense that this, if I take 4 of these and I build something, I'll have a cube octahedron, because I have a cube, a square here. I'll have a square here. This is already a cube here. I can have the same cube here. I can have there. I'll have 3 cubes, three cubes that intersect. Can you see this? I'll have a square here and another square at the basis here, and you do that.
Cool.
Okay. We can read further. Let's continue.
Joe, you put a little explanation about the tetrakaidecahedron.
Yeah.
And did somebody raise their hand? Did I see you raise your hand? Richard, go ahead.
Yeah, I'm just interested as we talk about the Star of David. Again, my little experiment some time ago in wondering whether or not the major symbols of the or the symbols of the major religions might have manifested themselves out of the tetrahedron, or the 2 triangles that form the tetrahedron. And so I found the Star of David. I could do it with the Christian cross. I could do it with the Buddhist or the Hindu swastika. And for the longest time, I couldn't discover what it might be in the Islamic faith. And I had it answered very quickly by a Bucky disciple some years ago, who said, well, that's easy. It's the Seal of Solomon. They're exactly the same. So then I've been kind of looking up the Seal of Solomon and the Star of David, and find that they're not exactly the same. One is kind of a 2-dimensional overlay, Star of David, and the Seal of Solomon is 2 triangles interwoven with each other. And that's how you tell the difference. But I'm always interested, as we're trying to find ways to experience the notion of harmony and cohesion, that when we talk about something like the Star of David as an example, we should always be also talking about the Seal of Solomon, or at least recognize one to the other if we're making reference to one over, or by way of example, one instead of the other. But they need to be kind of referenced together in a way that we understand the manifestation from what I think is the basic tetrahedron.
I didn't know if anybody has seen the Seal of Solomon. I just looked it up. And I'll share the screen. And let's hope I can find it. It's over here. There it is, Seal of Solomon. So there's the Seal of Solomon. And the Seal of Solomon is unique.
Can't see anything yet.
It
Okay.
has a circle around the Star of David. Is that what you have recognized, Richard?
No, you have to see, there's a different graphic that shows how the two triangles are interwoven or
like
inter-
like an usher painting.
yes, right. And
There it is there.
Oh, yeah, that is interesting.
yeah, there you see it. And
Well, actually,
that one right there.
this one right here, right? Yeah. Yeah, it shows the entwined. Let me see, I'll click on that. That should make it bigger. Oh boy.
Oh, it sucks.
This is when we go down the rabbit holes. I should have right-clicked and just brought up that particular graphic is what I should have done. And nowadays, when you open up anything, you end up, I find that I'm getting all sorts of pop-up dorky things. Yeah,
Yeah, we're sort of back in the 2000s when we had pop-ups all over.
Yeah, yeah.
We came full
Okay,
circle.
good. That's nice
720.
to know. This is the Seal of Solomon. I had an epiphany about the seal, this Melchizedek symbol of Melchizedek. Oh, here's an interesting one.
Yeah.
It
But
has
you
all
see,
sorts.
Steve, show the one that, look at that one. Okay. You don't see, there's no intersection. It's not in 2D. Look at the way it is. It is two, it's a yin and yang. It's a two interwoven triangles.
Yeah, like a
right?
Mobius band.
Yeah. It's like look at it. You know, there's no cross. It is.
Yeah. It's interwoven.
Yes.
Yeah.
Yeah, and that's interwoven, and the Star of David is not. It's just overlapped.
Yeah. Well, it's flat. It's 2D. They're trying to show a 3D representation in 2D here. Very cool.
And is that all the symbols of the major things in the world that you have?
No. The other is that if you take the tetrahedron, like a two-dimensional drawing, you can rub off some of the edges and you'll end up with a Christian cross. If you take the tetrahedron or the Star of David, or the two triangles that make up the Star of David, and you open them up and you slide them together, you can slide them together in a left-handed or a right-handed swastika, or you can actually fold them in an angled swastika, which is the negative one that everyone's familiar with. And you see the same thing in in a indigenous medicine wheel. So what I was trying to get at as to whether or not there is a common sort of symbol or structure that has allowed the manifestations of all of these different sort of faith symbols that manifest themselves in a way that they are often in conflict with each other, but they come from the same source.
Yeah.
It is our sun. The most common experience is our sun. And depending on the position where we were deployed, we see the sun at different angles. And we make representations of it that is function of that angle. I think it is where we are deployed as humans in relationship to the sun historically. And then we make, as we evolve, we make a representation of that sun that we see, and then we feel it as the source of energy that we manifest in our body. I think that one basic feeling would be that the nourishing, that is what we call energy, the nourishing accumulation into us and expressed out from both the sun and the soil that we walk. I do think that at the very beginning of the evolution, that's what the beings felt. Those two, and depending on the position where we are, and based on our awareness of that, we deduct something. We make a representation on something that reflects the observer, as we were talking about. We need to make sense in a 720-degree way. That is in a cycle way. One cycle is 720 degrees. It's a double tetrahedron.
I'm not sure where you're going with this, but it just, we were working with triangles, and my discovery of our awareness, I guess, of how two triangles go together to form four triangles, the tetrahedron, and then looked at how two triangles can come together to form the Star of David, the Seal of Solomon, the Christian cross, the different swastikas, and perhaps the indigenous medicine wheel.
I will say something. If I'm born,
but just you might, kind of relate to what I was kind of thinking about and sort of surmising out of my work with the two triangles, whether or not that makes any sense, or whether or not I've put the triangles together in a way that doesn't represent the symbols of different faiths. Just interesting for me. That was all.
Okay. Let me take.
Go ahead.
Before you go ahead, I placed again the maritime people structures from critical path because it's there also. Can you see it?
Yes.
Okay. That's all I wanted to say. Go ahead, Manu.
Okay. If I'm born at the equator, let's say you're born in Hawaii, and Joe is born in Pennsylvania, and we live a year, how many seasons will we count?
Repeat the question.
I am born at the latitude of the equator.
Yes.
That's where I live. That's my life.
There's no season.
You are born. Yes. I see 2 seasons.
No season.
No, I see raining season, raining. I see the monsoon and the dry.
It's more equatorial. That's more, yeah. Okay, go ahead.
Okay. And now you are in Montreal or in San Francisco. We are revolved the same year.
Yes.
You have 4. So what representation, which representation of God, knowing that this revolution gave us all that we needed to go in a year, will I make at the equator end? And I'm still same sentient being. I will make a representation of 2 things at the equator, most likely, and the representation of 4 things, because I have 4 manifestations that are very different.
But you also have the equinox that's probably similar in all those locations.
Yeah, but I'm not sophisticated enough to perceive equinox, because those symbols were 2,000, 4,000 years ago. My point here is that the experience and the representation that I will make, the symbol as the symbol, which is the space holding the accumulation of my experiences. That's what we call symbol. And that is multiplicative and integrative, is going to be something different depending on my local conditions. But addressing what is like the same thing, is the same sun that we see. We know it now. So for me,
So how do you connect what you're saying with what I was saying?
how I connect it is that I will need, for me, from the equator, to know your stuff. With lack, I will have to come experience your thing. Now, what is the cost of my plane ticket to Calgary? Is what you will need. And it happens with lag at the cost.
Well, that's a cost, whereas you could have two triangles in your hand and I could have two triangles and we could create the symbols that we would like to create out of those two triangles. And they may be similar or they may be different.
But what I'm saying is that
that's what was all I was trying to get at, is taking two triangles, two stable sort of systems, put them together in different ways, different kind of linking ways, and you end up with different, what looks like to me, different face kinds of symbols that have come from the same sort of same structural source. That's all. And that may be a reflection of what you're getting at, is that I'd put the triangles together in North America in maybe a different way than you would do it in South Africa.
I'm just saying, the fact that you decide to take and put together to build something more complex is exactly what we call evolution. You have complexified your universe by the act of, you have to account that you have now taken two triangles and putting them in a certain way. That act counts. So when you're doing the accounting of that universe, it becomes more complex. I first have this one that was just this, and this somewhere else. Now I've decided, because of certain intuitions, to take this and come and put it like that. There, you see here I had only one color, and there I have only one color. When I decide to do this, how many colors do I have? How many sectors can I describe? 4. This, 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 and this. At least 4, probably 5. But I've complexified, I've created the tapestry of what is being shown on the screen now, by the fact that I've acted based on my experience to take this and come and put it like that. I have to account it when explaining what we have, the tapestry that we have. It didn't happen on its own. We build that universe.
Okay,
that was my point.
And we're moving into our time. Fred, your hand is up, and I'm very curious as to what you are representing here with this beautiful diagram.
I'm sharing, the starting point was Richard's remarks on assembling triangles different ways and shifting them in order to create reduced symbols. And this came from the fact that somebody mentioned Islam. Am I right? Yes, somebody mentioned Islam. Islam doesn't have a representation of God. But if we look at Islamic geometry, it is probably the richest in the world. They have developed 2D or 2+D geometric representations that are fabulously more harmonious, more complex than anything else in the world. That's what I wanted to say. So I wanted to share that as an illustration.
Exactly.
And
So
where does
you
this
want to-
diagram come from, Fred? What is this?
Islamic geometry, that's Islamic geometric pattern, probably copied from a mosque or somewhere.
Yeah, very cool.
Yeah, but you can also see in that diagram that they do a lot of interweaving, as
Yes.
opposed to just overlaying. Yeah, so the
But
Seal of
they-
Solomon is just a representation in a less complex way. But yeah,
Yeah.
They do
But
what
in
this-
Islamic
this-
stuff,
this is
in
a-
Islamic
this is a
stuff,
fo- This is a four-fold and eight-fold symmetry. What we're
Mhm.
talking about, triangle is a three-fold symmetry, 3 or 6-fold symmetry. But they
Yeah.
have Islamic geometry has a 3-fold, 4-fold, 5-fold, 6-fold, 8-fold, 10-fold, 12-fold, 16-fold symmetries, and
Wow.
that's a richness that we don't have anywhere else.
And it's
Look
time
at-
for us to
look
draw
at-
this.
look at-
Hey,
look at
Manu,
the-
Manu, it's
look
time
at
for
the
us to draw
symbol.
this. Manu, it's time for us to draw to a close, so please be quick.
Okay, I'm just saying that the Islamic crescent is this. And you look at this, it's parabolic.
Well, I'm not
It
looking
allows-
at the crescent. I was looking at the Seal of Solomon. That's all.
No, here, this one on my paper.
Yeah. Yeah, I know that was the one that I could always find, and it didn't sort of work out the way I thought it might until somebody told me about the Seal of Solomon.
Yeah. But I was thinking that about what Fred says, that it allows, it's not closed. It allows in and then out.
Very good.
It comes.
Okay,
Yes. All right.
okay. So it is time. We got only a few minutes left. We're going to go over. So as quickly as we can and as thoroughly as we can, don't feel pressured. Please share your feelings and your takeaways. Manu, how are you feeling and what are your takeaways tonight?
I feel good. I feel grateful, and I take away work in progress or understanding in progress. That's my major takeaway. So we are going to certainly revisit this, and I just have a feeling that it's going to be very rich. Richard, how do you feel? What do you take away?
No, I mean, I feel invigorated, and especially with what I was talking about just a few minutes ago, I always feel that in this kind of conversation, dialogue, that one can bring up these kinds of things and have some dialogue back and forth about whether or not there's some merit or something perhaps different or novel, or be able to challenge it in a way that produces a different way of thinking and adjustments or modification. So I always feel good about being able to get into a dialogue and come out of that dialogue feeling that I've had a chance to share something and had a chance to hear back from others in terms of their thoughts about it. So this is what's important to me about this kind of dialogue. And so I always get that good feeling out of the end of our discussions and the different kinds of takeaways that one can come away with. And so I come away just off of our last kind of dialogue, still feeling really intrigued with the possibility of symbols that represent major types of systems have a common base to them, which for me suggests that at some point we allow the diversity of the manifestations and respect them rather than try and divide and conquer any one of them, because it all comes from the same source. In this case, a geometric kind of source, but could be in the same way of I was just in a bit of a dialogue the other day with people that were talking about basically the philosophy and the integrity of the Christian faith and making a reference to God and so forth. And my reaction to it was whatever that kind of central figure might be. It could be a god, it could be a creator, it could be an Allah, it could be whatever, that we just connect with the concept and don't get too convoluted around the particular name that one gives or the particular way the message is being delivered. It's all trying to tell us to work in harmony and work together in common purpose and common good ways. So I take away that feeling tonight. Joel, how are you feeling? What's your takeaway?
I'm feeling pretty good. I'm just, again, really good to see everybody, and I appreciate everybody being here. I got to tell you, it's kind of a little bit connecting what Steve had started with some of the stuff Richard had talked about when you were talking about the relationships between symbols. And actually, Steve had brought up the idea of trees as how the AIs have come up with trees just as humans did. And that there is an underlying truth. And this is the hierarchical relationships that could actually also relate to language. So that language is not as arbitrary as we think. And we kind of known that through, how they accurately depict reality, but the idea that how you can compress concepts to have meaning, essentially the way the tree did. So the idea the tree is a natural form in language, and that you can have a family tree, a syntax tree, and a taxonomy tree. And that's like essentially kinship, language, and concepts. And that also relates to grammar. And you can kind of get to the idea of subject, verb, object when you get from there, and how recursive structures work. I mean, that paper you put in there, Steve, I mean, but you, in a way, it's getting to what Richard said, this idea how everything is interrelated. I know somebody that's actually working with compression algorithms and basically simplifying, trying to come up with a universal language that actually captures concepts correctly, that would actually align to how AIs can communicate to one another. I know that sounds pretty far out there, but that paper you put in there, Steve, it's really good. And I mean, it has huge implication for language itself, because of the idea of the shapes that we were thinking of, like that's my takeaway. I mean, I've been looking through that a little bit more deeply. And so anyway, so it's really, really, really cool. I know that was a little bit incoherent, but at the same time, I think I can defend it if I had to. Fred, how are you feeling? What do you take away from today?
Thank you, Joe. I've got two takeaways. The first is tetrakaidekaedron. I'll try to place this in a conversation with Chinese people this week. I'll tell you next week if I could. My second takeaway is AI is very, very extremely naive, because the description of family trees is not a tree, it's a graph. There are cycles in there and there's double edges, whereas a tree has a parent and children, and it only goes in one direction. That's not at all how family are related. It's a lot more intricate, I would say, than that. So that's my two takeaways. So Lee, how are you feeling and what is your takeaway today?
I am really feeling quite happy. I learned an awful lot this week that brought last week to an understanding. And when I saw, who was it that gave that design? It was Fred. Thank you. That was phenomenal. I love that. And how it could change from squares to diamonds to whatever and still make sense. That is math. And art, beautiful art. What was so interesting is that I am a collector of Native American artifacts, or not artifacts, but pottery. And I have several designs just like that they used and are still using today. And that is amazing. And that came how long ago? That design, that pattern of woven rope, Fred? How long ago?
That's several thousand years ago. That's woven things found in maritime.
In maritime.
Maritime seafaring
Yes.
populations. Yes.
Yes, yes, yes. Well, I see it in the knots of the maritime because I tied them a lot. I raised my two boys on a sailboat, and we used a lot of those. But what was so phenomenal was that the design, that's a gorgeous design that has been used thousands of years ago and are still being used today in artwork. I like that. And I am happy to share that with all of you, that art is in math. Love it. Now, who's left?
I think it's me.
Steve. How do you? Okay, I'll mute.
Well, finish your statement. Don't let me interrupt you.
How do you feel, and what have you come out of this whole evening?
Thank you, Lee. Thank you, Lee. I want to acknowledge that Joe put a little statement about in defense of trees in the deal. But I also would like to share that the article went much deeper, and I thought I would share this with you as well. This is the it actually explains as it starts to do math, it started to create this spiral helix up here.
Right.
And so that's Fred, it didn't just stick with trees. It was, these were hypergraphs, I'm sure of it, right? But he's trying to explain it to us folks out here, and so we understand trees. But the article is really quite good in terms of citing different papers, and even though it's a half-hour podcast, there are links to these papers in the podcast. So it's pretty cool. So in defense of trees, I might write a poem about that. I will say that this platonic solid idea and the shape of the universe, and everything, at least from one metaphor, everything is quantum. Electrons exist as perturbations on a quantum field that is everywhere. All these fields are everywhere, and they interrelate in ways that somehow create what I've heard as monism. In other words, we have a biological entity or a physical structure but it exists in the quantum field. It's, even though we see it as separate, it's one. And this idea of monism is a pretty profound concept that I bumped into today too. And then I'm remembering that Platonic solids are not solid, which is really profound because it seems like Western science always jumps on some aspect, leaving out something else. You know, if I have a Platonic solid, I'm looking at the faces, but in actuality, the Platonic shape is edges, which suggests boundaries. It suggests all kinds of space. And what I see in the face depends on my perspective. It just seems to me that, wow, I'm just so grateful for what I'm getting these days. And I really love my chirality joke, and I'm going to save it for another time too, because I think it's really cool. I also am kind of thinking about Richard sent out a thing one time. He just in community. It was fractal harmonics, and looking at that little graph that I showed you before of the AI built a graph on the language thing on doing math for trigonometry. Here's a quote from the article Richard sent me: "The spiral doesn't just grow outward." Thinking of dropping a water drop. I'm no longer going to use a rock. A water drop falls into a pond and it starts to create rings. But a spiral doesn't just grow outward like those rings. It remembers its core.
Right.
Ooh, that's so profound for me. Richard, that was really cool. And so a spiral remembers its core. That's just really profound. So anyway, I'm having so much fun here coming to life. It was a real honor for me to share my 1985 paper on belief systems and survival, the human, theory of brain. It's just really an honor to be with you guys and have each of you share your perspectives, and so profound for me. So thank you all very, very much.
Steve, when you say a spiral remembers its core, does that relate to beliefs?
I don't know. It's just something I'm pondering. It's just a little thing. I think it does relate to belief systems because
yeah, because what your memory is and what you're calling on and what is reinforced is the loop.
That's right. And
the spiral, remember, is polarity.
Yeah.
You understand? That's it. Yeah.
Okay.
So the spiral is traveling. It doesn't go like that. It remembers its polarity.
Yeah.
The polarity holds it together.
Yeah. It's how the planets move through the solar system.
Okay.
Actually move through the galaxy. It's how the planets move through the galaxy. So,
but we always forget the role of
headaches.
polarity. A polarity is that we live for a purpose. We might not know that purpose, but that's essential. We live for a purpose. So we are held together in a pole, in poles. No, but this is reality. We live for a purpose. We might be ignorant of it. Right? No, let me take care of that. We might be ignorant of it, but we live for a purpose. We are, every day that I wake up, in order actually to be productive, I should have a perspective. Otherwise, I just wander, and all of those things cancel out, and I live for nothing. Everything is in the background, noise. In order to achieve anything, we need to be anti-entropic. And anti-entropic means adhering, remembering what your purpose is for. Remembering your pole. I'm true. Steve,
okay,
I like this kind of free fall at the end. But
Steve,
any other free falling? Please go ahead.
Steve, you didn't put that main paper in there, the one you just pulled up.
Yeah, on fractal harmonics from Richard. I'll be delighted to do it.
Octahedron, the one from.
But Steve, you're going to email all of this, right?
There's another one.
Okay, I'll drop it in the chat here now, and then I will. So it'll take
email it.
You want to hang around it, and then I'll email. Then I'll stick all the stuff in the email. Yeah.
Yes.
Cool.
Because I tried to print your stuff. It didn't come out on my printer.
Wow.
You just printed something.
You tried to do what, Manu?
I tried to print this. I was printing this out. I just wanted to have a look at it. Your paper. The where the pi number 10 is could be
Okay.
placed in the figure above. I wanted to print this out, but it was a JPEG and the margin were not, I couldn't fix the margin properly. I need to edit it to print it out.
Okay. All righty, good. Any other comments or questions? All righty, great. I'm going to take a second and put this harmonics thing.
So next time we start from page what? Page.
Well, the next time I'm deducing here that we're going to actually start with truncated octahedron one more time, because it goes
Okay.
into a two-step review and goes into a table and stuff. So we're going to start on page 206, if that's okay with everybody. So we review the truncated the truncated octahedron, truncated octahedron. Okay, here comes Richard's paper
I
right
thought
now. If you don't want to wait for the email, it's coming in right now.
Your AI paper.
And the AI paper is there. That's the first one I put out.
That was only a page.
Well, it's
Page.
if you open that page, there's the link there to a podcast, and then we go to the link to the podcast, they'll give you the papers. What I
Oh,
sent you was just my summary of the podcast.
yeah, that's what I thought. Okay.
Yeah, so just go to that link, open up the description on the podcast, and you'll have the links to all those papers.
Okay, yes. I've downloaded Richard. That's fine. Yeah.
Okay, really good.
Good.
Oh, I
Thank you.
see.
Thank you very much.
Thank you all.
Have a wonderful weekend. Bye-bye.
You're my
too.
you're my
Bye.
heroes. Next week we'll see you.
Something shocking happened.
Bye-bye.